right, lesson 14, geometry. We're still in unit 6, coordinate geometry. Coordinate proofs. I hope that doesn't make you nervous. Proofs in coordinate geometry aren't quite as difficult. You don't have to write a lot of statements and such. So let's start out with which one doesn't belong, all right? And just tell me why. Why do you think which one doesn't belong? Okay, lots of different answers here. If I look at A, it's as silly as there are no numbers on the XY axis. I know it's a silly one. It looks like B, C, and D are all in the first quadrant, which is cool, right? Let's see. Here, got something touching the x-axis. Maybe that one doesn't belong. Okay, I think that A, C, and D all have right angles. Oops, right angles. So I think B doesn't belong. It looks like a diamond. Diamonds don't belong. Okay, looks like A and D could possibly both be squares. Okay, here's the only rectangle, etc. All right, so let's work on this first one. Name this quadrilateral. A quadrilateral has those 4 vertices. What type of quadrilateral is it? And explain or show your reasoning. So at this point, it would be very worthwhile if we had graph paper. But we're going to try to figure this out without graph paper, all right? Quadrilaterals are always made in order. Well, no. Let's just do this. I'm not in the first quadrant for everything, but I just want to do a really rough sketch. Okay, just really rough. I've got 0, 0. I'm going to name that A. Over 4 up 3. 1, 2, 3, 4. 1, 2, 3. Like I said, really rough sketch. We're going to name that B. Over 13 down 9. So if that is over 4, over 13 is going to be even further. 5, 6, 7, 8, 9. Let's say 13 down 9, somewhere down here. Let's name that C. Then over 9 down 12, which is even further. Okay, D. All right, so I think it looks like I might know what it is just from a rough sketch. Now we need to prove it. All right, we think it might be a rectangle. So let's check slopes. We know rectangles have to have right angles. So if I do the slope of AB to BC, I've got AB, the slope of that line is going to be the change in Y over the change in X equals a slope of 3/4. And then B to C is going to be change in Y. Doesn't matter which way you subtract as long as you go in the same, oh, that's X's. As long as you go in the same order, right? So change in Y. I'm going to do 3 minus a negative 9 because I'd rather add, but oh, then I get something negative on the bottom. 4 minus 13. So 3 minus negative 9 is addition, 9, 10, 11, 12. 4 minus 13 is negative 9. That simplifies to negative 4/3. Those are opposite reciprocal, therefore perpendicular. Cool. Now let's do, so I know this one's right. I'm going to do this one next, because if I know that one's right, then we can be done with all of them. Let's do CD and AD. So C to D, change in Y, negative 9 minus a negative 12 over 13 minus 9. So negative 9 plus 12 is 3. 13 minus 9 is 4. And then A to D, we'll do 0 minus negative 12 over 0 minus 9. So I get positive 12 over negative 9, which is negative 4/3. And those are opposite reciprocal, so we've proven that. What else do we need to prove to know that it's a rectangle? Well, nothing actually. Like once we prove that those slopes are all equal, we know that that is parallel to this is parallel to this, and opposite angles are equal, so we're good with a quadrilateral, right? So 1 is done. Let's look at 2 though. Find the perimeter. So we need to know the length of these lines, how long they are. You can either use the distance formula. Distance formula is the square root of x minus x squared plus y minus y squared, or you can use Pythagorean theorem. So if we do, let's figure out how big AD is using Pythagorean theorem. I'm just going to draw right. That's really bad. Oops. So I need the vertical distance for AD, which is just the change in y's. So that vertical distance is 12. And then I need the horizontal distance, which is just the change in x's. That horizontal distance is 9. And that's going to equal the diagonal, the hypotenuse. So 9 squared plus 12 squared is 225, which equals, I believe, 15. Yep, 15. So AD is 15 units, which means BC is also 15 units. So let's try the other one using the distance formula. So that was Pythagorean theorem. Now we're going to do the length of AB using the distance formula. So if I look at A, 0, change in x's, so 0 minus 4 squared plus change in y's. AB, 0 minus 3 squared. 0 minus 4 squared is negative 4 squared plus negative 3 squared. Remember, when you put those in your calculator, you need to put them in parentheses. So I get 16 plus 9 is 25. Square root of 25 is 5. So that distance is 5. So the perimeter is going to be 15 plus 15 plus 5 plus 5. So 30, 40 units. And then the area is just length times width. So 15 times 5 is 30, 60, 75, I think. Yeah, 75 units squared. Cool. All right, next one. Circular logic. So here we're going to observe that the angle formed by connecting endpoints of a diameter to a third point on the circle appears to be a right angle. And we're going to confirm it, okay, using a few different ideas. So let's first look at this. What kind of segment is BC in reference to the circle? So BC looks to be the diameter. Choose one plotted point on the circle and call it D. I don't know. Let's do this one. We don't have students in a group, so we're just playing along. We're going to draw a segment BD and DC. We've messed with segments like that before in circle, in the circle unit, and we know that angle D is a right angle, okay, because this measurement on the circle is 180 degrees, and the angle is half of that. All right, so we've actually proven that before. So number 2 just got way easier for you guys because I don't have to find the slopes of those two lines. we know that BD is perpendicular to DC. Therefore, the slope of BD is going to be the opposite reciprocal of the slope of DC. Okay, so for that one, we're good. All right, so we've got that. We're done. I love this. Just because what we've proven in the last unit, when we know the measurement of this angle, or what the circle is, which is 180 degrees, because it's half of a circle, because there's our diameter, we know that that is 90 degrees. In fact, I could do any of these because this is 180 degrees. This is half of 180, which is 90. All right, so we're proving it because we skipped ahead. We've got that one. All right, let's do one more activity before we call it a day. Okay, looking at these from the warm-up, we're going to just look at what shape they are and how we know. This first one is a square. How could we prove it's a square? First of all, we could do slopes to prove angles are 90 degrees. And then we can do segment lengths to prove segments are all equal. Okay, here we have a diamond. And, I mean, actually it's not a diamond, I'm so sorry. Rhombus. So we have a rhombus, and we would just show that no right angles, no perpendicular angles. But we do know that we could prove that all segments are equal length. Okay, because a rhombus is a squished square, and a squished square has all equal lengths. Here we have a rectangle. We already did a rectangle. We proved that angles are perpendicular and opposite sides are equal in measure. And then another square. Okay, angles are perpendicular, and you can do that with horizontal and vertical lines. And then opposite sides, you're just going to prove it this way, are equal. Cool. Good job.